lovely people, and welcome back to Learning with YagmanX. Today we're going to be carrying on with the series all about recreating the camera angles from our favourite horror games. Last episode we ran through Resident Evil's fixed camera angles, and today we'll be focusing on recreating the iconic alleyway scene from Silent Hill. Specifically how the camera moves in a very uncanny yet cinematic manner. So today we're going to go through how to animate a camera and how to get that camera to follow our player. So let's jump right on into Unreal Engine and get started. For this tutorial, I'm using Unreal Engine 5.1, but you can use any version. Older or newer will be relatively the same. I have just created a white box of the Silent Hill alleyway scene. I have done this by using the architecture pieces. So if I Control B on here, you can see I'm using wall 40 by 40 or 400 by 400 more. I'm gonna click and just drag this in because I realized that the first corner we get to isn't a complete 90-degree angle. So I'm just gonna add this in. Something like that will do. So just make sure you have some sort of hallway for us to use for this tutorial. If you need a recap on the very basics, like how to move around the Unreal Engine, please watch my first video. All information is in that one. Link will be in the description down below. And talking of that video, let's just look at the blueprints that we created before, just to give you a little recap. So I'm going to go into my blueprints folder and tutorial blueprints. So these are the two that we created in the last tutorial, BP Fixed Camera and BP Fixed Camera Sequencer. I'm just going to grab it and drop it into the scene here. Make sure the collision is overlapping our player start, and I'm just gonna point it this way and just Alt, or go back to W to move, hold down Alt and move to duplicate that actor, and I'm just gonna quickly show you. So these two cameras will change the camera view in a fixed camera style. So if I press play now, this first camera will be active. She's running in, the cameras are very low down. She's running in and they are swapping. So that's what we did in the last episode. Now we will be using a child of this blueprint. So if you don't know how to set this up, you haven't done it yet, please go check out that video. And I'm going to open up this blueprint now because what I asked you to do last episode was to add a delay in here to do an extra check for when the player is spawned in to see whether it overlaps, as the player seems to spawn in before our blueprint does, so this doesn't get called on begin play. As Luigi Masado rightly pointed out, delays should only be used if you're prototyping or if there's a dire need to use them. That's because they're blocking functions and they cannot be cancelled or reset through the logic. So actually the best thing to do if you do want to keep this logic in is to delete the delay, and we'll use a timer instead. So timer is always better than delays. So if we just put in timer here, and we can set timer by event, and then you put in your time for how long you want it to wait. I'm literally just going to put in 0.1 seconds. And you can drag off of this event and you can create a custom event. I'll just call it check for player. And then all we need to do is put our logic from this event. On event begin play, the timer gets run. The time is only 0.1 seconds. And then afterwards, it calls this other event called check for player. And it checks to see if the player is in the collision. Timers are super useful. You can change this time, you can set it to be looping, you can cache the return value, so you can always invalidate the timer, start it, stop it whenever you want to in the logic. It's just a lot better than delays, so it's good to know now. Okay, so we'll compile that, and you won't see any difference in the logic. It's still gonna see whether the player is within this box collision. So if I go into BP Fixed Camera, let's move that camera position so we can actually see. If you press play, yeah, there you go. There's just a 0.1 second delay for when it's checking to see if the player is in there. If you don't like that delay, I would advise you to simply put a Boolean. So go in here, put a Boolean of is starting camera. I actually got this ready earlier, and make that public. And if it's true, you can literally just plug it into here. And if it's true, then run on fixed overlap, but you'll have to set that up manually. It won't be checking for you. Just little cleanups from last episode. Hope that makes sense. One other thing that we did in the last episode was we set up a tank controls on our player controller. I want to go back into the player controller because I actually want to cap our walking speed, as I feel like the player is walking a little bit too fast for the types of funky camera angles that we want to create. So in the world settings on the right here, I look for game mode override, click on the little content browser icon, and it will take you to where the game mode is. And again, if we open up the game mode, it will show us what default pawn class we are using, and then we can click on the content browser button again and double click that one. As you can see, these are our tank controls. It's got the tank left and right movement inputs. And if you click on BP third person character in your components on the left, and then you can search for speed. And we want to change max walk speed. So from 600, make it 300 and compile. And now if we go back to the map and hit play, there you go. You can see the speed is capped out at 300. Okay, now that quick recap was over, I'm going to go a bit slower as we go through how to create a camera that moves in interesting ways along with the player. Let's delete all of the fixed cameras and get on with it. So first of all, I'm going to navigate back to my fixed camera blueprint, and we're going to right click on this one and create a child blueprint class. So click on that one, and what I'm going to call it is BP underscore fixed camera spline. Double click to open that one. I'm going to put it up the top here and close down my other blueprints. Don't need them anymore. What we want to do in this child blueprint is add a component of a spline. Here we go. A spline is a customizable path that can define positional data based on this path. So if we ensure that the end of the spline is always going to be at the end of our camera here and the bottom, then we can eventually use the spline to dictate where the camera is going to move. I'm also going to, in the right details of the spline here, scroll down and look for scale visualization width here. So I'm going to take this to be true, just so that you can see what the rotation is doing a little bit easier. As you can see, it's just displaying the rotation for you. Now we've got our spline, let's compile. And in the map, we're going to drop this one in. So I'm gonna just set it up really roughly. You can press F and that will guide you straight toward the blueprint that you're looking at. E to rotate. I'm gonna rotate my camera this way. Might help to get into top-down view actually. Press F again. Yeah, there you go. I can see a bit better now. So I'm gonna put this in the center of my hallway, and I'm just gonna set it up so that the collision is encasing the whole hallway here. Whenever we move anything within BP fixed camera blueprints, we have to go into their details panel here, which is up there above my head, and then click on the component that you want to move. And for the box, we want to change box extents when we're updating the box. So there you go. It's a bit longer now, and maybe this can be a little bit smaller. So the spline points, I'm just going to put one up the end, and one can stay relatively near the front. Back to perspective mode. Oh, the spline is in the floor. So let's click on the spline. And the camera actually. If you hold Control while you click, you can select multiple things. Can't speak properly today. And then there we go. We've got one spline point near the floor, so I'll keep that a little bit near the floor. And then what I need is one spline point up the top. Because if you look in the reference footage of the alleyway, this is the camera that goes from the bottom to the top, and it also rotates as well. So we'll set up the rotation in a little bit. But as you can see, the camera is still detached from the spline. So I'm now going to set up a function to be called through the construction script, where the camera will be automatically snapped to our spline. So let's go back into BP Fixed Camera Spline. Click on the plus next to functions and create a function called snap to spline. Now, if we get our spline, click and drag it here, we can actually get the spline length from that. And what we want to do is we want to lerp from 0 to the spline length. So whatever length our spline is going to be, whether that's 100, 1,000, whatever, this is going to lerp from 0 to that number using an alpha float, which will work as a percentage. So actually what we want to do is we want to right click and promote this to a variable. And I'm going to call this camera point. And we'll make it a public variable. Instance editable is the tick for that. And as you can see on the left, once I ticked that, the eye also opened to show that it's public. And we just want to give this a slider range of 0 to 1, and as well as a value range. So we can just slide the camera point up and down in our blueprint, and that will then update the output of the length on the spline point. You'll see, don't worry. So from this output, we want to get location at distance along spline for our spline, yeah. And we want to do this in world space. As well as that, we also want to get rotation at distance along spline. So we're going to be updating both the location and the rotation based on what the spline is doing. Don't forget to do this in world space. And that is because from our city camera, we are going to update its transform, set world transform here. And we can right click on the new transform and split the struct, and as you can see, it's split the transform. So transform is made up of 3 elements: its location, its scale, and its rotation. So we can just pop these into here, rotation into the purple rotation, yellow into the location. We'll keep scale as 111, and let's hook this up to the beginning of the function. So in construction script, we are going to call that function snap to spline, and the construction script gets run every time the actor is moved or resaved. So let's go into our map. So if, like me, your camera is a little bit off, that is because it's actually snapping to the spline points, and I have changed the location of my spline as a whole. So click on your spline, go into the details panel, see above my head here, and just reset the values, and then instead go into your spline and just update it by points. Let's see, point at the bottom there, and point up the top, and here we go. So it's a little bit annoying because it looks like my camera is faced the wrong way. I guess I could just rotate my whole my whole blueprint. There you go. And then I will get these points again and move that back and up, and then I can move this point down here. And there we go. That's way too close. That's much better. And now if we click on the details panel of the BP Fixed Camera Spline, you can see all of our public variables in the details panel under defaults here. So we've got blend time, blend function, which is what we set up last episode, and we have our camera point here. So you can actually just click and drag, and you can see the camera is going along with the spline points. This actually now will help me to set up the fancy rotation that happens on the first corner of the reference footage. So I'm just going to get get this spline point here, because I've only got 2. I'm keeping it simple. By the way, if you wanted to make more spline points, actually, I should tell you this. Click on the spline point, hold Alt, and you can just create another spline point here. But I only want 2, so I'm going to keep it nice and simple. Delete that spline point, keep my 2 that I've got. And I am going to work on making this one rotate properly. So I'm going to make my camera look down, because the camera does look down. And also it kind of looks over this way a little bit, maybe just 80 degrees here. And if you want to play around with the curves of the rotations, you can click on these offsets here and kind of move these around. As you can see, the curve of the rotation gets tighter or longer depending on where you're putting them. These ones are quite long, and I want to keep it looking this way for as long as I can, so I'm just going to make them a little bit shorter. If I go back to BP Fixed Camera Spline and go on my camera point, so it'll go like this, and then up like that. So one thing I've noticed is it's way too close to the floor. Something like this, maybe. Of course, it's just going to be a lot of little tweaks, but you can use the camera as a reference to see how you want to set up your spline. It really helps to do this in the construction script. However, if I press play, the camera still acts like our usual BP fixed camera. It's not going to follow the player yet, and that is what we need to set up now. So hit escape, and we are going to do this following the player logic in the tick. If we go into BP Fixed Camera Spline and go into the event graph, and you will see there already is actually a node here called event tick. The tick will run every single frame, whereas timers and delays, like what we spoke about earlier, they run based on seconds. So tick is really useful when you need something to move extremely smoothly. However, as you can probably imagine, if a lot of blueprints are running logic every single frame, this can suddenly get very expensive and really cause performance issues in your game. So we need to make sure that we're aware of when our tick is enabled and when it is disabled. So what we want to do is make sure that the tick is enabled when the player is within the collision box, so when that camera is being used, and then we want to disable it again when they have left the collision. Go into its parent class, which is BP Fixed Camera, and you can see we have set up last episode a onComponentBegin overlap, which calls this function of onFixedCamera overlap. We now want to do the same thing, back in the event graph, for onComponentEnd overlap, and then we'll just create a function that then all of the children can use. To be fair, all of the children can use the same onComponentBegin overlap anyway, but I personally think it's cleaner just to create a function that you know all of your children will be using, so that we can keep the same logic from the initial call and then have the function. That's just me. Everyone's different. Everyone does things differently. So click on your box collision in BP Fixed Camera. Scroll on down on the right here until you get to your events, and then onComponentEnd overlap here. That's what we want to add in. And just like onComponentBegin overlap, we just want to check whether the actor who's leaving the overlap is our character. Left click and drag to select all of these, Control C, and click again and Control V to paste. And then we want to hook up onComponentEnd overlap to the branch and hook up other actor to the input of the check. Then we want to add a new function called onFixedCamEnd overlap here. There we go. And compile. So that's the logic done in our parent, and we can use this new function now in our child. So if we go back to BP Fixed Camera Spline, I'm just going to delete event actor begin overlap because I do not need that one. And I'm going to add an override for the function calls of onFixedCam overlap. And I'm just going to enable tick here. Set actor tick enabled, yep, and we can turn that on. And we also want to override the end overlap here, and then again it'll be set actor tick enabled, and we want to make sure that the boolean is off. So now when the player goes into the collision, the tick is enabled, and when they come out of the collision, the tick is disabled. Now let's set up the logic from the tick itself. So go into event graph. So what we want to do every frame is to check where the player is along the spline. And then from that location output, we can use that information to change where the camera is along the spline as well. So let's get the spline, a little reference to the spline. And we want to find location closest to world location here. So the target is the spline, and the world location that we want to get is our player pawn actor location. Get actor location. Okay. And again, we're doing this in world coordinate space. And depending on the output of this, we're changing the location of the camera. So we're going to get world location, and we are going to interp to. So as this explains here, we are trying to reach our target based on the distance from the current position, giving a nice smooth feeling when tracking a position. So it's basically moving from A to B, but in a nice smooth way. And the way that you set up the smoothness is through delta time and interp speed. So delta time is what we're going to hook into delta seconds. And actually, to make this not be spaghetti, which blueprints can easily become spaghetti, I'm actually going to promote this to a variable. And then we can, instead of having loads of strings everywhere, every time we need to use delta seconds, we can just hook it in like that. So it's using delta seconds to interp to the target location, which is based on where the player is along the spline. And if we want this to be nice and smooth, we want to set up an interp speed. So this is interpolation speed. If the speed given is 0, then it will just jump to the target, which is not smooth. So let's promote this to a variable as well. We'll make this a public variable. So you know now if the eye is open, it is public. So we'll click that to be open, compile, and I'm just going to put this default to 3 for now. We can always change this on a per blueprint basis, of course. And after this, we can just set the world location from the output of the interp 2. And let's hook this up to, well, just after the setting of the delta seconds. I'm also going to separately update the world rotation based on what the spline is doing. I'm not going to do a transform like I did in the construction script because we are going to be adding quite a bit to this, and I'd like to keep location and rotation a little bit separate. So what we want the camera to do is rotate based on the spline's rotation as it moves through the location of all of its different points. So let's get our spline, and we'll find the rotation closest to the world location. And then we check to see, get actor, no, let's just get location. Yes. We check to see our camera's world location. And we're looking for the closest rotation, world again. And then from this, we want to interp again. This will be an R interp too. So whatever you're using, vectors, this is rotation. It'll just be a V interp or an R interp or whatever you're doing. And again, we're going to use delta seconds for delta time and interp speed for interp speed. And then our target, our target is from the find closest rotation to world location, and our current will just be the Cine camera's current rotation. Get world rotation, yeah. And there we go. And then the new rotation will be the output of the R interp 2. So let's compile. We'll go back into our map and let's give this a go now. So all looks good from the beginning. And then, oh, okay. So the camera is moving, but something is happening. Let me show you. You might have already picked this up, and if so, well done to you. Let me know in the comments. So if we hit, while the game is running, Shift F1, we get mouse control. This is really good for debug, by the way. And then you can hit this eject button up the top next to stop, but don't press stop. And now we can right click and move around like we do in the editor normally, but the game is still actually running. So I'm going to click on my BP Fixed Camera spline. You can already see the spline. The camera is hidden because it has this hidden camera mesh hidden in-game Boolean ticked. You can always tick that off and restart the game if you want to see the camera. Make sure you tick it on when you want to package your game though. So if I stop now, I can click on this camera again, click on Cine Camera, unclick the camera mesh hidden in game, press play again, Shift F1, eject, grab me player, and now I can actually see the camera. So you can see that it's moving, and it is correct. It's moving with the player based on where the player is along our spline, but it's moving at the exact same point, so it's just going to be constantly clipping through the player. How do we fix this? There's actually two ways that we can fix this that I can think of anyway, and I ended up using a mix of both of them to get the best results. So I'll take you through them now. The first way is to add a spring arm. So the spring arm's location gets updated to the spline and not necessarily the camera. So if we go into BP Fixed Camera, which is the parent of the BP Fixed Camera spline, and open up that one here, in its components, I'm just going to add a spring arm here. And the reason why I'm doing this in the parent and not the child blueprint is because I need the Cine camera to actually be attached to the spring arm so that when we make the spring arm longer or shorter, the camera's location will be changed basically because it's attached to the end of it. And if I just show you quickly, if I compile this one now and go to the fixed camera spline, which is the child, you cannot actually move any of the inherited components. So inherited components are components that are inherited from its parent blueprint. And as you can see, the selected component is inherited and cannot be reordered. So you need to reorder things in the parent. So what I need to do is just make sure that the Cine camera is positioned on the end of the spring arm, which it looks like it is. So I'm just going to click on Cine camera here on the left and drag and drop it on top of the spring arm component. Now do not be alarmed, the camera just jumped, but that is because the spring arm's length is 300. And now if we put it back to 0, it's back in its usual position. So this is why it's really good. If you want to put it minus, then it will go backwards. Because we might not need a spring arm for every single blueprint, we're going to keep this target arm length at 0. And I'm actually going to add a construction script call to set this target arm length per blueprint and then to cache that so it never gets reset. So I'm going to add a variable called spring arm length, and I'm going to make this a float variable and of course make it public. So tick the I for me, please. Compile, and from the spring arm, drag it over here and just set arm length. Yes, there it is. Set target arm length. And then we can drop our spring arm length float here. And whatever we set it to in all the individual blueprints, it will remain that. So I'm leaving mine as 0 down there so that the initial default spring arm length is always 0. But in my child blueprint, I will go back to BP Fixed Camera Spline. And as you can see in the construction script, we are actually running our parent construction script. So it will be doing this call of setting the target arm length. I just double clicked in that and it already took me to BP Fixed Camera, which is real handy. And now because I actually want to utilize this spring arm in the child blueprint, I want to make sure that the spring arm length is longer than 0 by default. And what we can do here, because you can't actually see it in the variables on the left, we need to find our inherited variables. So in my blueprint on the left here, there's a little cog. Click the cog and then click on Show Inherited Variables. And there you go. Now we've got all of the variables from our parent as well. You can see here we've got blend time, blend func, everything like that. I actually want blend function to be 2 seconds because the camera's always moving. I think it looks a bit nicer. And I will also update that spring arm length to be 200? Yeah, let's say 200. Let's have a look at it in the viewport. There it is. So our camera is now further away from its initial point because of the spring arm length, which we just set to be 200 by default. But this won't be reflected in the gameplay until we actually change our logic to update the location of the spring arm and not the cine camera. So we're going to quickly do that now. So let's go into our snap to spline. And instead of setting the world transform of the cine camera, we are going to click delete this and update the world transform of our spring arm here. If you go back to the map, now you can see that the spring arm is in use. And when we change the camera point, it's actually the spring arm that is moving. So the spring arm's up there now, and then it's moving down here. The camera's looking the wrong way, so let's quickly fix that. So go back into Fixed Camera Spline. I'm gonna just get the reference to the camera, and all we'll need to do here is set world rotation. And I'll bring this a little bit closer. And we can just set the rotation at distance along spline, like so. Okay. And now the camera is facing the right way. There's a little bit of a gap between the spring arm and the camera now because it has changed its rotation. Don't worry if that happens, you can always just update it. So we can just select the camera, hit W to move, and just make sure that it's on the end of the spring arm here. So whoop, 200. That would make sense. Let's compile. So there you go. So that's working for the construction script, and we just need to switch over all of our logic calls from the tick. So instead of updating the camera's world location, we want to update the spring arm's world location, which the camera will then be attached to. So if we just update anything that says getting the location of the cine camera, we want that to be getting the location of the spring arm. And we don't want to set the world location of the camera, we want to set the world location of the spring arm. The same for rotation. Let's click and delete the cine camera, and we just want to be getting the world rotation from our spring arm and getting the world location from our spring arm as well to see where it is along the spline. So compile, and now fingers crossed this will all work. So that happened because I have put the default blend time to be 2. I can change that if I want to. So what was happening there, weird, awful camera angle, is that the spring arm was doing a collision test, and if it ever found anything it could collide with, it was just being shortened. So I found, honestly, this has only brought me problems. So click on your BP fixed camera and click on the spring arm in the details, and just make sure that the collision test, do collision test, is just false. Just turn that off because it's more trouble than it's worth, honestly. And if we press play again, let's walk over. Then there we go. We can see that it's staying in front of our player. It's staying in front when she's over here, but then when she gets here, it's lagging behind. And that is because we can shift F1 out of here again and eject. If anyone knows how to roll the camera in editor, please tell me. This is gross. But yeah, so the player is technically closest to the point in the spline of which you can see the spring arm is coming from, because this is it's just too high. So we need to put it down and closer so that we can actually say that, yeah, this is closer to the person in question. See, if I put it all the way down to the player, then it goes down like so. Maybe moving it back as well could help. So I'm gonna just have a little play around, move it quite far down, and maybe I'm gonna make the spring arm like 250 for this blueprint. And let's play. Yeah, that will do for now, because my second way around this is to use dot product. Dot product measures how closely two vectors align, so we can basically use it to see if two actors are facing in the same direction. This way we can check to see whether the player is looking towards the camera or away from the camera. And depending on this, we can set a collision offset for whether we want to follow the player from their front or from behind. So we're going to set a player collision offset function, and based on where the spring arm gets set for its location, it's going to use this collision offset as well as where the player is in relation to the spline. So let's go into BP Fixed Camera Spline, and we'll add a new function called set player collision offset, because that's what we're doing. Let's do the dot product. So we want to get our cine camera, and we want to get the forward vector. Get forward vector from our cine camera, and we also want to get our player pawn and get the forward vector, get actor forward vector, and we want to do a dot product from both of these vectors. So this float will return the dot product of two 3D vectors. If the output is closest to 1, then that means that they are both looking in the same direction, which would mean that the player is looking in the opposite direction of the camera. And if the output is closest to -1, then that means that the player is looking at the camera, because they are both opposite directions. We're going to check that this actually is the case by putting in a print string, and we don't want it to be the duration. We want it to be, it will be converted from a float to a string, so it can be output onto the screen. Usually I would put a duration of like 20 seconds or something, but because this is being run in the tick, it's just gonna keep going. It'll just always be on the screen. So bear that in mind when you are done with this debug and you don't need a print string anymore. You can just delete it, but I'm keeping it for debug purposes. So what I'm gonna do here is from the dot product output, I'm gonna check to see whether it's greater than 0. So if the output is greater than 0, then we know that the player and the camera are looking in relatively the same direction, which means the player will be looking away from the camera. So we're going to use something called select here. And what this does is it uses a Boolean to choose a true or false of any variable that you'd like. It's actually really, really handy. Off, false, and true, we're going to hook up two floats, but let's just make them now. So in our variables, just add hit, and I want to make a float of player front collision offset amount. A bit of a lengthy one, but it tells you what it is. And let's make that public so we can change this. And also we want player back collision offset amount. So this offset will change whenever the player is facing the camera or the other way. And I'm going to make player front collision, you need to compile before you can set anything. I'm going to make player front 300 and player back will be -300, because we're actually going to be multiplying this from the forward vector of the player. So if you multiply it by a negative number, then it will go behind the player, and a positive will go in front of the player. And so let's hook these up. So player front collision, if it is not over 0, then we're going to use a player front collision, and we're going to use a back collision for true. And then our return value, we're just going to promote to a variable. And this will be a private variable. We don't want to change this ourselves. We want this to be handled by this logic here. And that is just going to be player collision offset. There we go. Okay, so hook all these together. And now that we have this, we need to make sure that it's being run by the tick. So go back into event graph. And after our event tick and setting delta seconds, we're just going to call it here. So set player collision offset there. And as you can see, this is where we are setting the world location of our spring arm in relation to where the player is closest to the world location of the spline. So we're going to keep this the same, but we're going to add to it. So let's get the forward vector, and we want to multiply this with the player collision offset that has been set in this function here. So you need to make sure this function is being run before this logic gets run. So now we've multiplied it, we just need to add it to the actor location. And then from that output, we will put that into find location closest to world location. So now instead of the spring arm going to the location that is closest to the location of the player itself, it's going to go to the location that's closest to the location of the player, but with the multiplication of the player collision offset. Now, when you're just setting this up, maybe you need a visual reference of where this offset exactly is, and we can show this to you by doing a draw debug sphere. I use these quite a lot whenever I'm setting up any locational logic. So let's hook all these up. So basically the center of our sphere will be the player pawn's forward vector with the multiplication of the player collision offset. And we'll just make its radius a little bit smaller because that's how large it's going to be. We'll make sure that its duration is 1. It's going to be on tick though, so it's just going to be there all the time. And thickness, let's allow this to be too thick. Oh, too thick. Okay, so let's compile and see if that worked. So we should, yeah, we've got numbers on the screen which dictate, oh damn, that is a thick sphere. That the numbers on the screen dictate the dot product, so what's coming out of that. So it's almost -1, which is what we would expect because the player is facing the camera. And because of that, we can see that the sphere is being made for us. And then all of a sudden, the sphere is now behind the player. If we go back, the camera and the spring arm is based on where the offset is, not on the player themselves. And you can see that by the visualization of the sphere here. Remove the sphere when you actually want to start playing, but it's a good visualization to know where locational points are. So I'm going to hit escape now and go back into my BP Fixed Camera Spline, and I am just going to remove that draw debug sphere. It's not a sphere, it's a sphere. And just hook these up again. So there we go. And tell you what, that has also really helped us out with the camera not getting to its end point, because now we're looking for an offset location, which is in front of the player, so it's moving a lot more smooth. However, once she goes around the corner, she's gone, bye-bye. You might be thinking, hey, I know how to fix that. I'm just gonna add another spline point, so hold Alt when I have a spline point selected and create one here. But as you can see, number 1, the rotation has just been absolutely balked. But number 2, in our reference footage, there you go, so we can try like that, but it's not gonna work. In our reference footage, the camera goes from being in front of the player to then going behind the player. And I couldn't find any elegant solution to put this all in one spline. I'll just quickly show you what I mean. So it's doing all this, and now it's gone through the wall, and also it's just the wrong rotation just all the time. So we need to have a separate blueprint for the next section. And what I'm going to do is I will just blend between the multiple blueprints because we have our blend time down here, which is 2 seconds. So I'm going to set up another version of this blueprint and I will show you what that looks like in a second. Okay, so something like that. I've got now 2 fixed camera blueprints. I've got this one that does its fancy little spin up to the top, and then I just have this one that is literally a straight line from point A to point B. So I'll just show you what that would look like. Okay, so as you can see, yes, it's behind the player, which is good, but it's not looking in the right direction. It needs to look down. Now we could manually set up the camera each time to rotate in certain ways, but I think what might save us a bit of time is to have the option to have the camera rotation actually follow the player if we want to, on X-axis or Y-axis, so horizontally and vertically. Because right now the camera is actually following the spline rotation, and even if we try to make the spline face the floor, you can't keep that with all of the spline points because then we've just created a really weird spline transition, and it's just going to get messy. See, it's like a big scary roller coaster. It's going upside down. We want to keep it simple here. So let's add the option for us to be able to look at the player with our camera. Back in BP Fixed Camera Spline, let's add 2 booleans down in our variables here, and we could call this one horizontal player follow and make this a bool and public. And then we can just duplicate this one and call it vertical player follow. So we can easily turn this automatic rotation on and off on a per blueprint basis. If we scoot over here all the way to the end of the logic from our tick, we just want to have a check for these booleans because we only want to do this if we have said, yes, I would like one of these to be true. So I'm going to search for or. So if either horizontal player follow or vertical player follow is true, then we want to do the next part of the logic. So if you want to make one actor look at something else, that actually is this really handy function called look at rotation. And you have a start and a target. So our start will be our cine camera, and we want to get actor location, or get location, get world location, that's the one. Zoom in so you can see this. And then our target obviously will be our player pawn. And we just want to get the actor location. There you go. I only want to affect the Y and the Z axis because Y is vertical and Z is horizontal. If you also want to affect the X axis, feel free to create your own Boolean for that. But if not, then just follow me. So I'm going to split this struct. And what I want to do is change the current cine camera's rotation based on either of the Y or Z from the find look at rotation. So just like we've done before, get the cine camera and we want to get its current rotation, get world rotation. And from this, I want to interp its rotation. Yeah. Using, of course, our delta seconds and interp speed, which is here. Now let's split the struct of the interp too as well, as I don't want to change X. So I always want X to stay the same, so I'm going to just copy and paste the get world rotation, split the struct and make sure these are always pinned together. I'm just going to move this over so we have a bit more space. There we go. And then to set up Y and Z, we want to use selects And if vertical player follow is true, then we want to make sure that Y is being used from find look at rotation. If not though, we'll just use the rotation that the camera already has. And the same with Z, we'll use a select again. And if horizontal player follow is true, then we want to use the find look at rotation Z value, and if not, then we want to use the cine camera Z value. This is getting a bit into spaghetti territory, but it is what it is. And then from this, we will set the camera's new location. Rotation. Here. Okay. We have somehow sloped up a mountain with our nodes, but it's okay. We can always fix them up a bit later. So let's go back to the map, and on our second blueprint, we will go down to where we have our variables in the details panel, and I'm going to just set it to do both. Follow it horizontally and vertically. So let's play that one now. And there we go. Now we're looking actually down at the player themselves. And also what I noticed in my reference footage was that when the player was walking towards the camera, if they looked left or right, the camera would actually move with them. So actually this first camera also needs to follow the player. And I'm just gonna have them follow vertically as well, because it might help us with the end of the spline where we want them to be completely looking down on the player. So I'm just gonna show you now. See if they're walking over here a bit or walking over there. The camera is updating with them, and then it kind of helps to make them go around the corner a bit smoother as well, which is lovely. Obviously it still needs a bit more tweaking, but I really think we're getting there. I think it's good. So for this one, I'm just going to quickly update its box extents, because we want this camera to keep on ticking after they have gone around the corner. Because in our reference footage, they keep walking for quite a while around the corner and the camera kind of peeks at them. It's like looking around the corner at them. So I'm just gonna update camera point to be 1 so I can have a look at where it is. Yeah, so I need to put this point a little bit further here, just so that the camera will be able to peek around the corner a little bit and be a little bit creepy, you know? So the reason why I've made the collision box so big is because it will keep on ticking as the player is walking kind of down here. I'm also just going to make these blend times 1 instead of 2. I think 2 is a little bit too long for them. Actually, this first one, I'm just going to make it 0. Nothing at all. Make sure that you put your cameras back to where you want them to start, or they'll be zooming all the way back to the beginning of your spline and you might get some weird camera issues. So yeah, do that, and then she goes around the corner and then it's following her, and then she goes around the corner. Yes, and it's kind of like, yes, it's peeking at her. There you go. It's like it's a peeking camera. And now it's stopped ticking because we've gone out of the collision box. But that's perfect. That was really good. Well done, me. And now I will just quickly make another duplicate of this and just have one for it to follow her down the hallway. I know it's a her, but obviously, just imagine this is Harry Mason, okay? So now we'll be walking, it'll do this little rotating thing, it'll look down below us and go, wow, you got a nice head, very shiny and metallic. It'll follow us here, it'll peek at us around the corner because it's like a peeping Tom thing, and then it blends to the other camera and just keeps on following us down the hallway. And just something for polish, if you want your cameras to automatically focus on the player, we can set this up in the parent if you would like to, and then we can make this available to all children. So if we go into on fixed cam overlap and then get a reference to cine camera, and then we can just, I think it sets focus target or something. We can set focus settings, And then here we can make camera focus settings down here. And what we want to do is set them to manual, because I think right now they're on auto. And we want to do track focus settings. We want to make tracking focus settings. So we're just making a lot of stuff over here. And active to track would be our player. So get player pawn, or player controller probably would work as well. And there we go. That is how you would do that. I'm just going to put a Boolean so I can ask, should focus on player. And if the Boolean is true, then it will automatically update the focus settings when we have overlapped with the fixed cameras box collision. So branch here, should focus on player. If true, then update the focus settings. And I'm just going to set this Boolean to be true by default, because it's always nice when the camera is focused on the player. But of course, we go back into our map and say we have this blueprint selected right now. We can always look in our details panel and see down the bottom here, should focus on player. We can make this false. And once you've tweaked and found out exactly what you want, you can end up with something a little bit like this. And there we go. Thank you so much for watching this tutorial. I know it's a little bit finicky, splines always are, but because of that, I'm going to put up this project somewhere where you can download it. I'll put it available for Patreons. So if you want to have a little play with it yourselves, maybe tweak it, make it better if you can, then yeah, feel free to. The link to be a Patreon, it will be down in the description below. So there you have it. Now you know how to animate a camera along a spline based on where the player is. I hope you found this useful, and I hope it inspires you in some way. I know splines can be super finicky, so it might take you a while to get the desired result. If there's anything that I have missed that helps make this method a bit easier, please do let us know in the comments. As always, this channel is about sharing my findings with you, but also us learning together as a community. I gotta say, when I first started looking into this, I thought it would be so much more simple than it actually was, but hey, that is game dev. Nothing is as simple as it seems. If you have any suggestions for interesting camera angles in your favorite horror games that you'd like me to cover, please do let me know in the comments, because I would love to continue this series. And also I'd love to say a massive thank you to my Patreons for all of your support. Everything you do really helps this channel plod along, because we're not the biggest, but we have a lot of heart, and you know I put a lot of time and effort into everything that I do, and I know you appreciate it, so thank you. It means a lot. If you would like to be a Patreon, the link is in the description down below, and if you would like to see more of my face, then there is also a link to my Twitch, where I stream every Monday and Thursday. So yeah, maybe see you there. But if not, that's fine too. I'll see you in the next video, whenever that will be. So, that's about it. Have a lovely day or evening. I will catch you in the next one. Goodbye. There's so much doubt. Every tutorial video I make, there is so much doubt, self-doubt. It just eats away at me, gnawing away. Is there something wrong with my lens? Or is that just the light reflecting off it?